Okay, this is question 8 from our shadow paper. It says, water is being pumped into a tidal lagoon. The depth of the water, d meters, keep an eye on that, is modelled by d equals 4 plus 3 lots of sine 30t for 0 to 24. Where t is the number of hours after midnight. That seems like a detail that will be quite important. A maintenance craft enters the lagoon at 7:15 a.m. and must remain alongside a platform for 1.5 hours. Okay, something about more than 5.2. Right, so something we want to spot early on really is t is the number of hours. So there's going to be some conversions in this question. In fact, if we do the first one, find the depth of water when the craft enters the lagoon. T is not just equal to 0 in this case, so we can't be too lazy with it. We've got to read. It says it enters the lagoon at 7:15. Well, 7:15 means that t should equal what? It must be 7.25. Okay, so for part A, I think it's just going to be a case of, let's write this down here. So for part A, it's going to be a case of D was equal to 4 plus 3. It was sine 30t, so that's going to be 30 times, what was that number? It was 7.25, so 7.25. Okay, so if we work that one out there in degrees, okay, there's a small degree symbol there, we should get an answer of, I get 1.879 meters. It says what depth, so we should really specify the units. Okay, the units can cost you quite a few marks on pure papers, so it's good to just put them in because you're never quite sure when you might be marked down for that. Determine to the nearest minute. Nearest minute, we might use that button on our calculator, you know, the one that sort of has sort of lots of degree symbols and so on. If you don't know what I'm talking about, I'd encourage you to look around. That's often quite useful on these kind of questions. Nearest minute, the earliest time the craft can depart. We're not allowed to just use a calculator or something. Okay, so now I've worked with, what's that, 7.25 before is the first one. The earliest that it can leave, well, it says it must remain there for 1.5. So I think we say t equals, what's that, 8.75 is it's the minimum, isn't it? Okay, we're only looking for values that are bigger than that. There's another condition as well. It's only when it's 5.2 or more. Okay, so this is really a question about sine graphs. I'm going to do a few things. The first thing I'm going to do is I'm going to adjust this domain for 30t because I think it's not going to be hard to get solutions, but it's going to be quite hard to sort of think about all the conditions. So it would be useful. This would save us a bit of time. So 30t will still be 0 there, and 24 times 3 is 70, so that's 720. Okay. So we're only looking sort of up to 720 before we adjust. I think we want to put the 5.2 in, don't we? So let's do 5.2 equals 4 plus 3 sine 30t. So this is a kind of a solving question, really. It's about t. If we take away the 4 and if we divide by 3, that'd be 1.2. So let's say 1.2 equals 3 sine 30t. And then we'll get 0.4. Okay, this is the part where it's worth slowing down a little bit. So we're interested in when we get 0.4 on a sine graph. Okay, 0.4 and above, because it also said, didn't it, it has to be at least that. So if I draw a quick sine graph, I'm not going to worry too much about all the different details and transformations and so on, but hasn't been reflected or anything like that. So just drawing a basic sine graph is actually quite useful to get me thinking to start with, okay? So we're looking for sort of 0.4. Now, if I solve, so if I do inverse sine, yeah, if I do inverse sine of 0.4, that will give me values of 30t. I'm going to write down my principal value first, which is, it's 23.5, I'm going to call it 23.58. That's the first value my calculator gives back, but it's not just 23, is it? The 23 is here. It's the other values that go with it. So, you know, how do you get that one there? Well, for that one, for example, you do 180 minus, don't you? So it's often really useful to work that value out first as well. So it's 23.58, and the other value is 156.42. Now, that would be 30t, wouldn't it? So let's just see. I'm sure that 23 divided by 30 is far too small, so that's not going to be relevant. This one here, well, there's a problem with this, isn't it? This is the 156 will be here, and then it will be too shallow at that point. So I'm not interested in it, but I'd encourage you just to think about, if you did this number divided by 30, it's about 150, isn't it? So 150 divided by 30 is 5. So I'm getting close, but even that would not be enough. So I think we can safely say that now we've got our principal and our partner value. I think what we want to do here is we want to add on 360s, because remember, when you've got a pair of values for sine or cos, you always add 360s on. So I think we want to add on 360 to both of these, and then have a little bit of a think about it from there. So 23.58 plus 360 gives me 383.58. Let's just do the other one while we're here as well. So 156.42 plus 360 gives me 516.42. And I don't think I'm going to be able to fit any more in there, am I? Because look, if I added 360 onto that one, it would actually send me beyond that. So I think the answer's something to do with these numbers here. Okay, so these numbers are also equal to 30t. Okay. Now, let me just go back to the question. It can only leave when the depth is at least. Okay, so if this number here, when I divide it by 30, is bigger than the minimum time, then that's going to be the answer, isn't it? So 383.58 divided by 30 is, I get 12.78. Okay, I get 12.786. I get that from my t value. So that's the first number of, that's the first amount of time after midnight that the boat can depart. I'm just going to check if I need to do anything else. So yeah, as soon as it gets to this value, it's fine, isn't it? It's fine for it to depart. So what's the answer? Well, the answer is going to be, well, it's 12 is midday, isn't it? Personally, I don't really like the idea of writing AM and PM with 12, but I suppose it's after 12, so it's 12 something PM. The 786, what you can do with the 786 is you can put that into your calculator on the right mode, and it should tell you what to do. Alternatively, you can do 0.786 times 60, and it should give you 47 minutes. So I believe I get 12:47 PM. Okay, so this should be the first time that the boat is able to leave the harbour.